So on number 20, 20 is pretty easy. Circle. 22 is pretty easy. That was a circle. Are we all good on those two? Now let's look at 23. Stop doing your homework tonight and look up here. I'm a little worried about this problem. 3 and 3 are the same value. It's a cardioid. So you know there's going to be a dimple at the pole. So that one to me is pretty easy. 24 was pretty easy because it's a cardioid. You know the dimple is at the pole. You said, Miss Fisher, I ran out. I extended and drew another little ring there. So just do your best on that, okay? Now, number 26 was just a monstrous big one. Mr. Chester had to get real creative on that one. Alright, so this is a lambison. A lambison. The A value, the absolute value of A is greater than the absolute value of B. So I know there's going to be a dimple, but there's not going to be a dimple at the pole. So I have to think, okay, where's my dimple going to be? Do you guys see how these 2 points are on the same line, like equal distance from the pole? It's not, the dimple's not going to be there. The dimple's either going to be here or here on those other 2 points. You see this one's closest to the pole. That's where your dimple's going to be. Does that make sense? Okay, I know this had to go out to ring 9, so that's 6. You saw I drew a ring here, 7, 8, 9, and just kind of extended it. Just do the best you can on that, okay? Oh. 7, 5, 7, 9, and 7. Does that make sense where the dimple's going to be at? Better, Tyler? Okay.
I just have trouble remembering which one's a swirl and which one's a dimple.
Okay, okay. Here you go. Okay, I'm going to teach you one. I call it a swirl. Some people call it inner loop. Inner loop. Because isn't a swirl an inner loop? If your A value is less than B, less loop. Less loop. That's the way you can remember it. You like that, Jackson?
So if it's, are all the swirls always going to be within the 2?
Yes.
Okay, and if it's a dimple, it's going to be outside of the 2. Okay. Yes, that makes more sense to me.
Now, guys, I will tell you this. If you okay, the swirl, the calculator always draws the swirl. If you graph it in your calculator. But the calculator does not draw the dimples. So if you graph this one right here on your calculator, it's not going to have this dimple. It's going to look like a circle. So I just want to warn you, if you graph these, it's not going to have the dimple. Because the dimple is so small, it just makes it look like a circle, which this is not a circle. So don't rely on your calculator for the appearance of these, okay? Is everybody good on that? Okay. All right, any other questions on that? Do we feel better about that? Okay. Well, yesterday, now we're going to learn a final one, the rose. Okay, what does the rose look like? What's the difference between the rose and the circle here? The circle is a number times the trig function. Is a number times the trig function. But look at the rose. You have a number times a trig and another number outside. So you got 2 numbers in here. One in front of the trig and one in front of the theta. That's how you know it's going to be a rose. A circle only has the number in front of the trig. Does that make sense? Okay. We watched the video yesterday, but we're going to start back from here. Alright. Okay, so we're going to identify some things. This number out here in front lets you know what ring you're going to draw your petals out to. That means you're going to draw everything out to the 5th ring. Okay, that's the significance of that number. No, it's not always going to be 5, but that is significance. This tells you, the inner number tells you if it's even or odd. If the number sitting there is even, you're going to multiply it by 2, and that's how many petals you're going to have. Like in this one, I'm going to have 4 petals. In this one, it's an odd, isn't it? You don't do anything. That's how many petals. For an odd one, that is the number of petals you're going to have. I'm going to have 3 petals here. I'm going to multiply this by 2. That's going to be 4. You see how to determine your petals. Okay, let's talk about this. How many petals would this one have? 3. How many would this one have? 8. Do you see how that works? Okay. Alright. So, what you do, guys, if it's, okay, so this is an even flower, even rose. You take this part right here, and you set it to 1, and you set it equal to -1. If it's an odd one, you don't set it equal to -1. But even, you set them both. You have to have one set equal to 1, -1, and explain that process. Just stay in the video. Now, you got to ignore the 2 right now. Ignore the 2. And just think, okay, what sign value gives you a value of 1? Pi over 2. So now you're going to put 2 theta equals pi over 2 plus, we talked about this yesterday, for the period of a sine function is 2 pi n. What sign value gives you a -1? 3 pi over 2. Okay?
Does that mean the first 2 quadrants?
What that, buddy?
Then you also do like
That's the only values that give you a sign value, negative and 1 and positive 1.
especially why are we adding 2 quadrants?
Because there's a rule about on these that you have to do the period of a sine function. You remember when graph period is like the period of a sine function is 2 pi? That's why that case. It's a long proof.
Will it always be 2 pi n?
For sine and cosine, yes. We don't graph tangent. So. Alright, it's always going to be plus 2 pi n. Okay. Ooh, somebody's yelling. Now I'm going to divide everything by 2. When I say pi over 2 divided by 2, it's going to be what? Pi over 4, because you got to flip that 2 and you're multiplying by 1/2, aren't you? So that's pi over 4. These 2's cancel. Now, you're going to get the same number of petals from each equation. So if you have 2 equations, how many answers are you going to get from the first equation? 2. How many are you going to get from the second equation? 2. Just over here. Alright, so what you do then, guys, is you start plugging in values for n right here. The first value plug in is 0. What's 0 times pi?
0.
So 0 plus 1/4 would just be what? 1/4, which is pi over 4. You always start with 0, yep. Next, you plug in 1. What's 1 pi? Pi plus 1/4. So it's really like you're adding 1 and 1/4, which is what? Pi over 4. So you got your 2 answers from that one. Now you got to go to the other one.
So do you always just plug in 0 and 1?
Sometimes you have to go to 2. It just depends on how many answers you need for it.
How do you know how many you need?
Okay, so right here I had 4 petals. I had 2 equations. 4 divided by 2 is 2, so each of them is going to give me 2.
What about
If I had 8, if I had 8 petals on that one down there, 2 equations, I'm going to get 4 answers for the first one, 4 answers for the second.
You just go with
Yeah, you go like, okay, since I got to get 4, I'm going to plug 0, 1, 2, and 3 in them. Does that make sense? All right. Now if I plug, now I got to divide this by 2. That would give me what? 3 pi over what? 4 plus pi n. If I plug 0 in, that's going to give me 3 pi over 4. If I plug 1 in, that's going to give me 7 pi over 4. I'm just saying 1 plus 3/4. If you can't do that in your head, just put that in the calculator and it will tell you. So there's my 4 petals. I'm going to put a dot at the origin. Now I'm going to go out to the 5th ring for each of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Oh wait, don't you have to multiply? Oh wait, never mind. I see.
And there's your answer. Isn't that so pretty? Yes.
So whenever you're solving the equation, is it always dividing by 2, or are you just trying to get theta by 2?
You're trying to get theta by itself. So you're going to watch it. It's going to make more sense. We're going to 3 more examples. It's going to make sense. Now, on number 10 there, is that an even or odd one? You're only going to have one equation for odd. That means you only set equal to positive 1, okay? You don't do the second part. So, I'm not going to worry about that 5 right now. I'm just going to do sine 3 theta equals 1. That means I got to get 3 answers from this one equation, okay? What sine value gives you a value of 1? What is it? Pi over 2. Plus 2 pi n. Now, what do I got to do to get theta by itself here? Divide everything by 3. When I say pi over 2 divided by 3, what does that give me? Pi over 6. Okay, think of this. 1/2 divided by 3. You're going to say 1/2 times 1/3, aren't you? And that's going to give you 1/6. Now, if you cannot see that, please type in your calculator, okay? Now, what would this be right here? 2 what? 2/3 pi n. 2/3 pi n. So I got to get 3 pedals. What have I got to plug in for n? I got to plug in 0, 1, and that's your 3 values, okay? 0 is easy because that all cancels out, so you're left with pi over 6. Now plug 1 in. That's 2/3 plus 1/6, isn't it? Y'all see how I got that 2/3 plus 1/6? Don't worry about the pi's. You're just adding fractions. 2/3 plus 1/6 would be what? 5/6. So I'll put 5 pi over 6. Now, if you cannot do that in your head or see it, is Mr. Hess going to get upset if you use the calculator? No. Mr. Hess is impressed if you get the right answer. Not if you can do it in your head, okay? I want the right answer. So don't be scared to get that calculator right now and start typing. So I'm going to pretend like I don't see it. It's fine. Okay? Now, I'm going to plug 2 in. What is 2 times 2/3? 4/3. So 4/3 plus 1/6 is what? 9/6, which reduces to 3 over 2. So there's your 3 pedals right there. What ring am I going out to? 5th ring. Very good. Put a dot at the origin. Now you're going to graph it. And there's your flower. Come a long way since I was a trick-or-treat again.
Doesn't matter how big or small.
If you want to make them fat leaves, that's fine. If you want to make them skinny leaves, that's fine. If you want to make them pretty, it doesn't matter. I'll be looking for those 3 flower petals. Alright, let's look at number 11. What ring will I go out to on this one? Second, is this an even or odd? How many equations will I have? So I'm going to set what equal to 1? Cosine 3 theta. What? Ignore the 3 right now. What theta value gives you a cosine of 1? Now the question is, some people say, do you use 0 or 2 pi? Use 0. We never use 2 pi, we just use 0, okay? So it's 0. So you're going to say, oh, this is going to be real easy. Yes, it is. So you're going to put 3 theta equals 0 plus 2 pi n. Because the cosine of 0 gives you 1. That's why 0 is sitting there. Now you can divide everything by what? 3. So I get 0 plus 2/3 pi n. So if I got to have 3 pedals, I'm going to plug in what 3 numbers? 0, 1, and 2. Yes, Jack?
Leave that 0 out.
Yes.
Like theta equals 2/3 pi.
You can do just 2/3 pi n if you want to. Now if I plug 0 in for n, what's 0 plus 0? 0. If I plug 1 in, it's just going to be what? 2/3 pi. I plug 2 in, it's going to be 4 pi over 3. So there's your 3 leaves. So you're going to go out to the second ring. Is it making sense? Now what's wrong?
So I put 2 pi over 3 plus 2 in my calculator, give me 8 pi over 3.
Why did you put plus 2? Because there's no plus 2. It's times 2
Okay.
is 0.
That's what I did.
All right, number 12. What type of rows is this? Even or odd? Even. So how many petals are you going to have? You're going to have 2 equations. So how many answers are you going to get per equation? 4. All right, so here we go. All right, I'm going to say cosine of 4 theta equals 1, and cosine of 4 theta equals what? Negative 1. All right, where does my cosine value give me a value of 1 at? 0. Plus 2 pi n. Where does it give me a negative 1 at? Pi. Very good. Ooh, this is going to be really easy because they're all whole numbers. No, well, never mind. We've got to divide by 4, so there goes your whole numbers. I'm going to divide everything by 4. That equals 0 plus pi over 2 n. Divide by 4. Theta equals pi over 4 plus pi over 2 n. Alright, I plug 0 in. What do I get first on this first one? If I plug 0 in, I get. If I plug 1 in, I get. If I plug 2 in, I get pi. Now, let's 2 times 1/2 is 2 over 2. That's why I get pi. I plug 3 in, I get. So there's my first 4. I plug 0 in. That gives me 0, so I got pi over 4. Now, I plugged 1 in here, guys. So you need to calculate 1/4 plus 1/2. That's going to be 3/4, won't it? We sure? Okay. I plugged 2 in. 2 times 1/2 gives me 1 whole, don't it? 1 whole plus 1/2 would be 5/4. And if I plug 4 in, that gives me 2 plus 1/4, which would be what? 7 pi over 4. So there's my 8 petals right there. You got 4 there and 4 on the other. So let's graph them. Now, what range do you go out to? 3. Very good. Look at that pretty flower. Why don't you just pride yourself you can do something like that? We're not done yet.
So you plugged in at the bottom of the numbers.
On here, I need the 4 answers I plugged in 0, 1, 2, and 3. They gave me 4 answers. 0, 1, 2, 3. All right, let's turn over to page 8. We're going to do what we just did at the beginning. We're going to identify to make sure we understand. I don't want you to know everything. I just want to know the name of it, okay? It says circle, Cartier, Levinson, rows. So here we go. Number 21. I'm going to let you think before. I want everybody in unison. What is 21, guys? Circle. Very good. Put that down. Number 22, what is that? Levinson. Now, you just write the word Levinson, but you're going to tell me what it's looked like out loud. It's a Levinson. Your A value is bigger, so what will it have? A swirl or a dimple?
Dimple.
Dimple. Will it be at the pole?
No.
Thank you. I love that confidence. Good job. Number 23. Notice the structure here is -7 sine 10 theta. What is that? A rose. Very good, because there's a number there. Is it even or odd?
Even.
How many petals would that have? 20. Very good. I'm not going to make you graph anything like that. But yes, that would have had 20 petals.
Oh, yeah, you're right. What is that -7 do? What is that -7 do?
That -7,
Nothing to do with it.
it's just orientation. Number 24. What type is that? Lambison. Okay, the A value is less, so it would have a what? Swirl, inner loop. Very good. 25. That's a circle. 26. What is that? Cardioid. Very good. Now, that means it has a dimple at the hole. 27. What type is that? Even or odd? How many petals would it have? 5. Very good. 28. What type is that? Very good. And what type? The A value is greater, so will it be at the pole? Okay, you have your homework. Does anybody want a Krispy Kreme donut hat?
I'll wear it.
Don't wear it all.
Can I get your signature on it?
Can we have your signature on it? Yeah. So he took me a picture earlier. We're going to get a picture of Krispy Kreme and actually right on that thing. It's called instructional rounds. We go from teachers to teachers learning, and other teachers as well.
I'll do it. So I put that paper on my mouth and walk out my hall. Get that to you and I'll say it's my
Yeah. Yes, ma'am. If you get something with pi over 8 tonight, don't worry about that. We'll talk about that. That must be a bad problem. Happy Pi Day.
I mean, can you still technically solve it?
Pi over 8, I ain't showed you where pi over 8 is at on each of the circle. Alright, y'all have a good day.
Don't we have a checkpoint today? Yes. Yeah, I think it's pretty easy, right?
Yes, it is. It's pretty easy. We've been rocking and rolling today.
Tuesday? Yeah,
Can you put one of these on everybody's desk, please?
I told maybe it's going to
Who was the girl that you asked out? Who? Oh, I don't know her. Oh, gotcha. This is for next year, Bailey. Y'all have a great day.
She got their phone from water also? Yeah. Yes. Yes.
Yes! Yes!
My head's so fat. Oh my god.
Oh, I went up to the field house to get them to like do stuff to me. And I didn't know if they'd be there or not, but I figured it out. Kobe!
Oh, we get it done. That's fine.
Oh, it is Pi Day.
It's always going to be something Micah, but I found out. Are you there?
My mom was like,
This morning. I'm like, I told Melissa and Aiden we got flight tickets. They have it. But I did not come to school, no matter what time the flight is. Oh my gosh.
Happy Pie Day!
Mr. Hester, I have something for you.
You have a hat?
Can I get a hat?
Yes, you can. I got them for you. Just a second. Sit down. Can I find out where the hat? I'm here today. Oh my! It's on a blue and orange.
Oh my gosh, oh, wait.
Hey, Alyssa, what color? What color do you
Who rocked this?
That's
We actually had it.
Happy Friday. What color?
No, it's not a green.
Let me do a blue actually. Thank you. Where'd you get these?
I'm going to send it to you. They're trying not
No, you know who is like random
He said, wait, Noah. He said, wait for that. I'll pass the rest of them. Happy Friday. If you don't believe your seats, you're not getting one. I can.
Yeah, get push forward.
I get one.
That'd be an element.
Hey! No, you're not. He may actually fight.
There you go.
I gotta stand up.
Hey, hit with the.
Connor, what's it called? The Moroccan?
Hey, no, took my game.
Please sit down when you're not getting done.
I couldn't sit down. That one wouldn't even slap.
Oh, baby.
Wait a second. I said first thing I'm sitting back. I'm not cutting pie all day. It's circle. That's what. I don't do it one. But I'm wearing it. No, I'll take it all. Who else wants to take it for practice?
Well, their instructor was committed to South Carolina.
I don't know what's that.
Put your hats
Not
on.
with the best, but nobody from Alabama goes Stevie. So, thank you.
Happy Pie Day. You don't have to though.
180 something was the fastest person.
All right, smile at me for Pie Day. Smile.
Today is not the day.
Wait, I want it in it.
Okay, I was going to take a picture of that side of the room too. Connor. God. Alright. This side of the room. Jesse, I'm not getting your face. You just keep your head down. You're good.
What's wrong with our face?
Nothing. You just don't want it.
Alright. I'm going. And down the side, you get one.
Oh, yeah, I got one.
You're acting way too.
Thanks, Mr. Oswald. You're welcome. Does anybody else have their beta club money today? It's due today. You can bring it tomorrow. That's for seniors. Juniors, you get your notes next week.
Can I get to the restaurant?
Alright.
Can I get to the restaurant?
Y'all.
We got a surprise.
No, take that to Miss Stepstone and Mr. Gray.
Yes,
Say Happy Pie Day.
Yes, sir.
What is in your... What is that? What is that? What do you have in your shirt?
It's my whole binder.
Why?
Can I take them with those?
No. No. Alright. Here we go, guys. We talk about pi every day in here, don't we? 2 pi 3, 5 pi over 3, pi over 4, so it's a special day. It gets this.
Oh, can anybody memorize the numbers?
Now, I had Clayton Nichols last year could recite up to like the 40th, 50th digit of pi. And just like that. I'm glad. 3.14. Alright. I am ready to start. You will not get another surprise if you cannot eat and work. Okay, so let's turn to our math workshop. And I want you to do 5, 6, and 7 now. And do it. Do not talk to your neighbor. Work it. Yes. After you do 2 problems.
Good process.
What? There's always a pencil up there. We were doing so good. Don't do your problems. Hold on. I've been still recording since the first period.